Iborn, we are going to start the 2021 English medium class. We have already covered the syllabus. So today I am going to start from the questions. So until the exam, we are discussing the questions, mainly the past papers and also the model questions one by one. First of all, I have to discuss the 2020 paper. That's the most recent paper what we have. අපි මුලින්ම කරන්නේ 2020 පේපර් එක. දැන් සිලබස් එක ඉවර වෙලා තියෙන මේ වෙලාවේ 2020 පේපර් එක මුලින් ඉඳන් ඩිස්කස් කරගෙන කම්ප්ලීට්ලි යනවා. එතකොට ඔයගලන්ට මේක නිකන් ප්‍රශ්නෙට උත්තරේ විතරක් ඩිස්කස් කරන ක්ලාස් එකක් නෙමෙයි. හොඳට සිලබස් එක රිවයිස් කරමින් තමයි අත්‍යවශ්‍ය දේවල් හොඳට නැවත නෝට්ස් දීලා උගන්වගෙන යමින් තමයි මේ පේපර් ඩිස්කෂන් එක යන්නේ. ඒ නිසා මේ ඩිස්කෂන් එකෙන් ඔයගලන්ට ලොකු දෙයක් කරගන්න පුළුවන්. හැමෝම සම්බන්ධ වෙන්න අපිත් එක්ක දිගින් දිගටම විභාගය දක්වාම අපිත් එක්ක ඉන්න අපි හොඳ පේපර්ස් ටිකක් ඉස්සරහට කරගෙන යනවා. ඒ වගේම උගන්ගේ සිංහල මීඩියම් රිවිෂන් එකටත් ඔයගොල්ලෝ නොමිලේම අපි සම්බන්ධ වෙන්න අවස්ථාව දුන්නා. ඒ නිසා ඔයගොල්ලෝ සිංහල මීඩියම් රිවිෂන් එකෙත් වැඩ ටික කරගෙන ගිහින් ඇති මේ වෙද්දී. ඒ නිසා රිවිෂන් එක අඩුපාඩුවක් නැහැ. සිලබස් එකත් කලින් අවසන් කරපු නිසා දැන් ඔන්න අපිට හොඳ රිවිෂන් ටිකක් කරන්න පුළුවන් පේපර්ස් එක. මම හිතනවා දැන් 2021 පේපර් එක ඔයගොල්ලන්ගේ අතේ ඇති කියලා. මම දැනුවත් කළා groups වල message දාලා කම්ප්ලීට් කරලා ඇති කියලා 2020 පේපර් එක අතට ගන්න. දැන් මම එකින් එක ඩිස්කස් කරන්නම්. එතකොට මම බෝඩ් එකේ ලියලා අවශ්‍ය දේවල් සාකච්ඡා කරාට පස්සේ ඔයගොල්ලන්ට පුළුවන් වෙනම කොලයක් අරගෙන ඒ කොලේ Tamanට වීඩියෝ එක පෝස්ට් කරලා නෝට් ඩවුන් කරගන්න. The first question is 2020 MCQ. Question number 1. A computer processor will operate fastest when the data that it wants is in the. So which memory type is the fastest among these memory types? First of all, I will discuss the theory. If you consider the CPU is the fastest component in a computer. It's process the data and control the whole computer, all the devices. CPU contains the registers. So the registers, fastest memory type available under the static memory made using the transistors. Then the CPU contains the cache memory. Cache memory is in level 3 levels, level 1, level 2 and level 3 cache memories. They are also made using the transistors. So under the static memory or the static RAM, they are also fast but not fast as the registers. Level 1 cache is faster than the level 2 and level 2 is faster than the level 1. Then in computers, the main memory, it's also called the random access memory or the main memory. It's also called the RAM. Then the permanent storage device, hard disk or SSD. Hard disk drive or SSD is the storage device available in a computer. The operating system and the other software, all of them are stored inside the hard drive. So if you consider all these memory types, the fastest type is the registers, which can provide the data instructions to the CPU very quickly. Then the cache memory, then the RAM, and then finally the hard drive or the storage device. So a computer processor will operate fastest when the data that it wants is in the registers. But unfortunately, the registers is not under the answers. There are 5 answers. Among these answers, the first one is cache memory, the second one is hard disk, the third one is magnetic tape, fourth one is the main memory, the fifth one is the optical disk. Among all these 5 answers, the cache memory is the fastest. Cache memory is the fastest. So for the question number 1, the answer is 1. දැන් මෙතනදී මේ තියෙන answers වලින් තියෙන fastest memory එක cache memory. මේ question එකම ලබන අවුරුද්දේ ආය ඔයගලන්ට එන්න පුළුවන්. බැරි වෙලාවත් එහෙම ආවොත් සමහර විට මේ answer එක registers වෙලා තියෙන්න පුළුවන්. CPU එකට වේගෙන්ම data දෙන්න පුළුවන්. Instructions දෙන්න පුළුවන් memory type එක වෙන්නේ registers. ඉතින් මේ තියෙන answers වලින් උත්තරේ cache memory තමයි ගන්න වෙන්නේ. අවශ්‍ය දෙයක් තියෙනවා නම් වීඩියෝ එක pause කරලා ඔයගලන්ට you can draw the diagram. ඊට පස්සේ අපි question number 2 වලට යනවා. Question number 2. Which of the following hardware component will lose data when the power to the computer is switched off? This is about the volatile memory and the non-volatile memory. You know, the memory types available in a computer can be divided into volatile and non-volatile. The volatile memory cannot keep the data when the electrical power is disconnected. When the electrical power source is disconnected or when the computer is switched off, everything stored inside the volatile memories are erased. So what are the examples? The registers, RAM, cache memory, CMOS, they are under the volatile memory. Volatile memory. Then under the non-volatile memory, you can take the floppy, flash memory, mainly the SSD, then the hard drive, CDs, DVDs, Blu-ray, like optical storage devices. All these types, the ROM, they are non-volatile. Whether the electrical power is not available, the data is stored inside the memory chip without erasing. But if you go back to the past papers, the CMOS was considered under the non-volatile. Actually, the CMOS is a volatile memory, not a non-volatile memory. But you know, there's a small lithium battery is connected to the motherboard, which provides a constant power to the CMOS chip. So whether the electrical power is switched off or whether the computer is shut down, what is inside the CMOS is kept safe because of the constant electrical current is provided by the small lithium battery, which was installed to the motherboard. But compare when you are considering the available memory types here in the question, which of the following hardware component will lose the data when the power to a computer is switched off? Here, the A, which is registers, so volatile. The B is cache, C is main memory. All of these are volatile. So all A, B, C is the answer for the question number 2. The 5 is the answer. All A, B, C. Okay, if you want to write down something, you can pause the video and write down. Okay, then the question number 3. Computer has evolved from the early mainframes to the relatively small smart devices with high computing power used today. Which of the following inventions contributed to reduce the physical size of the computer? So you know that with the time the computers are getting smaller and smaller. So we have handheld devices today. So why they are getting smaller and smaller? Because most of the large electronic circuits can be designed in a small size because of the technology. If you go back to 100 years, the first communicating devices were made using the mechanical technology and also the electromechanical equipments. Electromechanical equipments like the relays, electromagnetic relays, the 0th generation of the computer. Then the vacuum tubes. Invention of the vacuum tubes is the start of the electronics. Then the transistor, computers made using transistors. So if you consider the vacuum tube computers and the transistor computers, the computers made using the transistors are very small compared to the computers made using the vacuum tubes. Then the integrated circuits. ICs. ICs are made using lots of transistors in one package, sometimes 10, 100 transistors, resistors, and other electronic components are packed into one package called the integrated circuit. It was made by the Robert Noyce and the Jack Kilby. Integrated circuits. Then the VLSI, very large scale integration, it's mainly the microprocessors, millions of transistors inside the same chip, microprocessors. VLSI, very large scale integration. So getting smaller and smaller. When we consider the answers available, the first answer is the bus, the second answer is the integrated circuits, third one is the registers, fourth one solid state memory, the fifth one vacuum tube. Computers are getting smaller and smaller because these integrated circuits have been invented. Okay, the best answer for this one is, for the question number 3, is the second answer, the integrated circuits. Many transistors packed into one package. Then to the question number 4. දැන් කම්පියුටර්ස් වල සයිස් එක ටික ටික පුංචි වුණා, කුඩා වුණේයි කියන එක තමයි මේ පැහැදිලි කරන්නේ. IC නිෂ්පාදනය කරපු නිසා. Consider the following diagram showing some hardware component connections on a computer system. මෙන්න මේ වගේ diagram එකක් ඇඳලා තියෙනවා. CPU, which contains a component called A. We don't know what's the component. This CPU is connected to the memory controller. The memory controller is connected to the memory. Then the memory controller, then this bus contains the video controller. Display unit, the monitor. Then keyboard controller. Keyboard controller is connected to the keyboard. Then the hard disk controller. The bus line connected to the hard disk. See this diagram. So the hardware part within the CPU, indicated by A in the above diagram, has a set of registers that has the memory translation maps of the currently running processes. When given an input virtual address of the current process, it outputs the relevant physical address, if any. So which component here, there's a component which converts the virtual address, virtual memory address is controlled, is translated by a component to a physical address. Virtual address is transformed into a physical address. So this is the component. What is this component? It's called the MMU, Memory Management Unit. දැන් මේ virtual memory address එකක් physical memory address එකකට convert කරන component එක තමයි මේ A කියලා මේගොල්ලෝ හඳලා තියෙන්නේ. the computer එකක තියෙන මේ component එක මොකක්ද කියලා අහනවා. ඒකට අපි කියන්නේ memory management unit කියලා, MMU කියලා. මේක අපි operating system lesson එකේදී අපි discuss කළා. ඉතින් ඔයගලන්ට මෙතන නම් ඇඳ ගන්න ලොකු දෙයක් නැහැ. මේක paper එකේ තියෙන diagram එක. මම ඔයගලන්ට ඒ original diagram එකත් ඇඳලා පෙන්නන්නම් නැවත මතක් වෙන්න ඕන නිසා. කොහොමද MMU එකෙන් මේ virtual address එකක් physical address එකකට translate කරගන්නේ කියලා. In computers, there's a component called MMU. It's called the memory management unit. This memory management unit contains a register which contains a value. Let's say 2500 is the value available. This register is called the relocation register. Relocation register. So the virtual address is given to the MMU. Let's say the virtual address is 5450 is the virtual address given to the MMU, memory management unit. And this virtual address is translated into a physical address by the memory management unit. How the physical address is created, this virtual address value is added to this relocation register value. 5450 is added 2500. So the answer is 7950 is the physical address created by the memory management unit. So when the CPU wants to access a particular virtual memory address, it is converted into a physical memory address by this memory management unit, which contains a relocation register. Value in the relocation register is added to the virtual address, so it will create the physical address. Right. ඔයගොල්ලන්ට වීඩියෝ එක පෝස් කරලා මේ memory management unit එකේ වෙන්නේ මොකක්ද කියන එකත් මෙතනදී මතක් කරගන්න පුළුවන්. ඉතින් මේ ප්‍රශ්නෙට උත්තරේට එහා ගියපු දෙයක් අපි ඩිස්කස් කරන්නයි මෙතනදී යන්නේ. වීඩියෝ එක පෝස් කරගෙන ඊටු ටික සටහන් කරගන්න. Question number 5. Consider the two binary numbers PQ. If x equals POQ and y equals PNQ, what will be the values of x and y respectively? So there are two binary numbers PQ. You have to perform the O operation and the AND operation. The P is 10110001. The Q is 01001110. The operation. When you perform the operation, all the bits are 1, because if one input is 1, regardless of the other input, the output is 1. Then the same two numbers are performed the AND operation. Perform the AND operation. 1 1 1 1 1 1 1 1. The AND operation. Sorry, the AND operation should be 0 0 0 0 0 0 0 0, because if at least one input is 0, the output is 0. AND operation. So the answer is, for the question number 5, the answer is 4. What is the 2's complement of the decimal minus 12? The question number 6. What is the 2's complement of the decimal minus 12? So first of all, write the 12, 0 0 0 0 1 1 0 0. Minus 12 in 1's complement can be written as 1 1 1 1 0 0 1 1. This is the 1's complement. To obtain the 2's complement, for this 1's complement, you have to add 1 1 1 1 1 0 0 1 1 plus 1 0 0 1 0 1 1 1 1. So this is the 2's complement. Which of the following is true about 2's complement? The question number 6, the answer is 4. This answer is 4. Question number 6, the answer is 4. Then the question number 7, which of the following is true about the 2's complement? An extra bit is used to represent the sign. No extra bit is reserved for the sign. There's a special another method called sign and magnitude representation. In sign and magnitude representation, the most significant bit is allocated for the sign. If the sign is 0, it's positive. If the sign is 1, it's negative. But here in complement arithmetics, we never reserve a bit for representing the sign. So the negativeness or the positiveness of the number is included within the number itself. That's how the negativeness or the positiveness is represented. Makes it possible to build low-cost, high-speed hardware to perform arithmetic operations. The second one, it's correct. Yes. Second answer is the answer. So most of the today's electronic devices are based on the calculation devices. Mainly the ALUs are made using arithmetic and logic units are made using this 2's complement method because it's very easy to implement the circuit compared to the 1's complement method. Addition and subtraction are used as two different operations. No, both addition and subtraction performs as the addition in complement arithmetics. Usually represented in hexadecimal number system. No, in binary number system. Used in first generation computers to perform logic operations. No, even in today's computers we use the 2's complement method for subtraction. So for the question number 7, the answer is 2. Then the question number 8. Question number 8, there are two tables. They contain some characters. The characters are represented in hexadecimal. So we'll see what kind of a table is it. In the table 1, Sinhala letters available. For Ayanna, 0D85 is the given hexadecimal value. For table 2, there are Tamil letters. They are also having different numbers. So they are asking in which, consider the character representations in table 1 and table 2 given below. In which of the character encoding systems given below, the above character in table 1 and table 2 are represented? Both table 1 and table 2 is in Unicode. It's the Unicode system. So for the question number 8, the answer is 2. Unicode system, there are 16 bits to represent a character. Here is in hexadecimal, so all these, each digit can be represented using 4 bits. So altogether 16 bits are used to represent a character. Then the question number 9, which of the following is the most simplified expression equivalent to this given Boolean expression? We see how it is solved. Question number 9 is electronics under the Boolean algebra. A B bar C bar plus B C bar plus A bar B bar C plus BC. So consider these two terms. C bar is common. C bar, you can apply the Boolean laws, distributive law. A B bar plus B. Here C is common. C in bracket A bar B bar plus B. Now you can apply the redundancy law here. C bar, here A plus B, C, here A bar plus B. Redundancy law is applied. Then again apply the distributive law. AC bar plus BC bar plus A bar C plus BC. Now consider the second term and the last term. AC bar plus A bar C plus, here B is common, within bracket C bar plus C, AC bar plus AC plus B, C bar plus C is 1, AC bar plus AC plus B is the answer. My answer එක තියෙනවා for the question number 9. The answer is the fourth answer. AC bar plus A bar C plus B. Video එක pause කරගෙන simplification එක ලියා ගන්න පුළුවන්. A block diagram of a sequential logic circuit is shown below, with one block labeled as A and the other labeled as B. So you have two blocks, A and the B. A contains an input and also A contains an output. Another output goes to B and it comes back to A. So you know there are two types of circuits, this combinational circuits What is meant by the combinational circuit? Combinational circuits means the circuits which contains the output of the circuit depends only on the present input of the circuit. The present output of the circuit only depends on the present input. Present output of the circuit only depends on the present input. Then there's another type, sequential circuits. In sequential circuits, the present output depends on the present input and the previous output. Previous output is also taken as an input for the present output. So, you know, the flip-flops are under the sequential circuits, and all the other circuits what we discussed, the logic circuits, are under the combinational circuits. So, the A, there are three statements. The first one, not A, the first statement, the block A is a combinational logic circuit. If you consider only A by neglecting this part, there's an input, there's an output, can be considered as correct. The block B is a memory element. Yes, data is given and stored and again given back. It's correct. Third one, only the block A can be implemented using logic gates. Only the block A can be implemented using the logic gates. No, both A and B can be implemented using the logic gates. Strong. Both can be implemented using the logic gates. So, for the question number 10, third one. Right. Video ko pause කරගෙන අවශ්‍ය දෙයක් තියෙනවා නම් ලියා ගන්න පුළුවන්. එකොළොස්වෙනි ප්‍රශ්නේ. Question number 11. Consider the following logic circuit consisting of NAND gates. That's a circuit, NAND gates. A and B is connected here. A bar is connected, X is connected, Y is connected here. The output is F. So, if the required output of the circuit is AB plus, this is the required output, AB plus A bar, B bar plus C bar. Then what should the inputs X and Y be? So first of all, you have to write the Boolean expression here with XY. So A, B bar dot A bar X bar dot Y, all things bar. Apply the De Morgan's law. AB double bar plus A bar X double bar plus Y bar. AB double bar is AB plus A bar X double bar is A bar X plus Y bar. Now compare with this one, AB plus A bar B bar plus C bar. X is represented by B bar, Y bar is represented by C bar, so Y is represented by C. So X is represented by B bar, Y is represented by C. So for the question number 11, the answer is 3. Question number 12. The operating system is another program that runs on the computer that has some special responsibilities. Memory management, file management, and input-output management are some of these responsibilities. What is another important responsibility of the operating system? Among the answers here, the backup management is not a responsibility, cache memory management is not a responsibility of the OS, compiler management, no. Process management, the answer 4 for the question number 12, the answer is 4. Process management. The fifth one is the system clock management, no. Question number 13. When the number of processes started by a user on a single processor computer increases, what happens to the response time of each process as perceived by the user and the memory management related work of the operating system respectively? When the number of processes increase, it will increase the response time, it will increase the memory management related work time taken for the memory management. So both the response time and the memory management related work is increased, because when the number of processes increase, it needs more and more memory management features, because for each process a particular memory location should be allocated from the main memory. So for the question number 13, the answer is the first answer. Then the question number 14. Which of the following is not a responsibility of the operating system? Allocating physical memory to process. Yes, memory allocation is one of the main functions done by the operating system. Deciding which process to run. When there are many processes in the ready queue, the algorithm, the scheduling algorithm decides which process to be executed next. Third one, keeping track of the usage of compiled program files on a hard disk. No, never keeps track of the compiled program files of the hard disk. Fourth one, keeping track of which parts of physical memory are in use, which are in free. Keeping track of which parts of physical memory are in use, which are free. Yes, it's a function done by the operating system. Fifth one, swapping processes between physical memory and disk. Yes, swapping in and swapping out is again a function of the operating system. So the question number, the answer 3 for the question number 14, the answer 3 is the answer. It's not a responsibility. Keeping track of the usage of compiled program files on a hard disk is not a responsibility of the operating system. Question number 15. දැන් මෙයා වීඩියෝ එක පෝස් කරගෙන ලියා ගන්න ඕන දේවල් තියෙනවා නම් ලියා ගන්න. In a computer, the size of a user program could exceed the size of the physical memory. Also, only the demanded areas of the programs are kept in the physical memory. The above are due to which of the following? This is a good question about the paging. I will erase. Okay, consider about the paging. Let's say in your computer, the virtual memory is available. The virtual memory contains the pages, page 0, page 1, page 2, page 3, page 4. Then the physical memory, contains the frames, zero, 1, 2, 3, 4, 5, 6, 7. Likewise, there are frames. These are called pages. These are called frames. Let's say the program is larger than the physical memory, so it is first loaded into the virtual memory. This page size is equal to a frame size, so whenever a particular page is required by the when a particular page is required to access by the CPU, request the page, it is copied to the physical memory. This P0, let's say, is copied here, P1 is copied here, P2 is copied here, P3 is copied here, P4 is copied here, let's say. Then there should be a table to keep track which process is copied to which frame, which page is copied to which frame. 0, 1, 2, 3, 4. The 0th page is copied to the frame number 4. The first page is copied to the frame number 2. The second page is copied to the frame number 5. Third page is copied to the frame number 0. The fourth page is copied to the frame number 1. It's called the page table. Page table. The page table contains the frame numbers of the pages which is copied to the frames. The frame numbers sorted according to the page number. This concept is discussed in operating system memory management. So here in question number 15, in a computer, the size of the program could exceed the size of the physical memory. Also, only the demanded areas of the program are kept in physical memory. The above are due to which of the following? Use of the pages, frames, and page table. Use of the pages, frames, and the page table. This complete mapping is here. If you want to draw the diagram, just pause the video and you can draw the diagram. All these diagrams are discussed in the theory class as well. Right. Then go back to the question number 16. Question number 16. It's about the compilers and the interpreters. Before going to the question number 16, I will explain about the compiler and the interpreter. What is a compiler? The compiler translates the whole source code into an object code. This process is called the compilation. The source code written in a particular programming language, the source program is completely translated into object code, which is made by the binary number system. This translation is done by the compiler. So to compile a particular source code, it should be 100% syntactically error-free. Then the other translator is called the interpreter. You have the source code. The source code contains statements. Each and every statement is translated and executed. Each and every statement is translated and executed. No object code is created. So even there's a syntax error, you can translate and execute until the line which contains the syntax error. That's the advantage behind this interpreter. Which of the following statements regarding compilers and interpreters are correct? A compiler transforms an entire high-level language program into its machine code. Compiler translates the whole source code into the machine code. B, an interpreter converts each high-level program statement into the relevant machine code during the program run. Yes, correct. Compiled codes usually run faster than interpreted codes. Yes, the compiled object files can be executed very fast compared to the interpreted codes. For the question number 16, the answer is 5. Then the question number 17. Question number 17. You know about the compilation and interpretation, so you don't need to write down these things. All these things are discussed. Which of the following statements regarding guided and unguided media are correct? You know about the guided media and unguided media. What are the guided transmission media? Guided transmission media made using the physical components. It's a physical medium made using sometimes the copper cables. There are two types of copper cables: twisted pair cables and the coaxial cables. Again, the twisted pair cables are two types: UTP cables and STP cables. Then optical fibers made using glass or plastic. There are two types: single mode optical fibers and the multi-mode optical fibers. They transmit the data as optical waves. Then is the guided transmission media. The unguided, radio waves, infrared, laser, microwave. The microwave can be divided into two types: terrestrial microwaves and the satellite microwaves. Terrestrial microwaves and the satellite microwaves. So it's about the unguided media. Which of the following indicates, which of the following statements regarding guided and unguided media are correct? Guided media transmission supports higher data speeds than unguided media transmission. Yes, correct. Let's consider the optical fiber, which can provide very high speeds of data transmission compared to all the other transmission media. A is correct. B, guided media is subjected to less interference than unguided media. Yes, it's correct. Compared to these unguided transmission media, guided media is very low in interference, especially the optical fibers. Copper cables are sometimes interfered by the external electromagnetic waves, but optical fibers never interfered by external electromagnetic waves because optical fibers are made using glass or plastic. Unguided media transmission is more secure than the guided transmission media. No, the C is wrong because the most secure method of transmitting the data is the optical fiber because no one can tap the signals. Unguided media transmission uses low bandwidth than guided transmission media. Yes, it's correct. The highest bandwidth is achieved by optical fiber. What is meant by the bandwidth or the frequency bandwidth? Frequency bandwidth is the frequency difference between the lowest frequency and the highest frequency which can be transmitted through the medium. You can obtain the highest frequency bandwidth by this optical fiber. So A, B and D only. This is the answer for the question number 17, second answer. If you want to write down something, you can pause the video and write down. Question number 18 is regarding the modulation techniques. What are the modulation techniques we discussed? Analog modulation. We discussed AM, FM, PM. Amplitude modulation, frequency modulation, and the phase modulation. Then the digital modulation. ASK, FSK, PSK. Amplitude shift keying, frequency shift keying, phase shift keying. We discuss all these modulation techniques under the data transmission, data communication methodologies under the networking lesson. What is the process carried out by the modulation techniques in data transmission? The first answer, encoding information in transmitted signals. Yes, information can be encoded into transmitted signals. We'll take up with an example, then you can understand. Let's say ASK. Let's say you have a binary signal like this, which contains 1 and 0. It's given to the ASK modulator. The ASK modulator modulates the signal using two waves. The high amplitude is reserved for 1, the low amplitude is reserved for 0. Low amplitude is reserved for 0, the high amplitude is reserved for 1. So the amplitude, there are two signals, only the amplitude is different, frequency is same and the phase is same. High amplitude represents 1, the low amplitude represents 0. So the first answer is correct. Encoding information in transmitted signals. The information is encoded into the transmission signals. So that's the process of modulation. Then the question number 19. If you want to write down something, write down by pause the video. මේ උගන්නනවා නෙමෙයි මතක් කරගෙන යනවා ක්වෙස්චන් එකක් ආපුවම මේ ක්වෙස්චන් එකට අදාළ තියරි පොඩ්ඩක් මතක් කරලා දෙන එක මගේ යුතුයකම. Question number 19. Which of the following statements about the bus topology is incorrect? Before discussing the question, first of all, just have an idea about the bus topology. Bus topology shares the same medium by the computers and other networking devices. So this is called the backbone cable. So terminators. The same cable is shared among the different computers, set of computers. A. Computers and network devices are connected to a single cable. Yes. A is correct. All traffic flows are either clockwise or anti-clockwise. B is wrong. No clockwise, no anti-clockwise here because it's a linear cable. C. Bandwidth is shared among the nodes. Yes, the bandwidth of the cable is shared among these nodes. These are the nodes. So they all can transmit through the same bandwidth. C. Bandwidth is shared among the nodes. It's correct. D. Each node is connected to two of its neighbors. It's wrong actually. This one is connected to these two neighbors, but here this one is not connected to two neighbors. Here the terminator, the other one is a node. The statement D is correct for the ring networks. If you consider a ring network, the ring network. So each node contains two adjacent nodes in left hand and the right hand side. Data can be transmitted clockwise or anti-clockwise. It's about the ring network. So we are talking about the bus network. So B and C are incorrect. B and D are incorrect. So for the question number 19, the answer is 4. Consider the following statements with the blank. Media access control address is, the MAC address, is usually represented in blank numbers. Which of the following is suitable to fill in blanks? You know about the MAC addresses? The MAC addresses are represented using hexadecimal digits. MAC address contains 48 bits. Representing 48 bits is very tedious, very long, so it's better to represent using hexadecimal digits. 4 bits can be represented using 1 digit. That's how it is represented. Okay, this is question number 20. The answer is 3. Video ko pause කරගෙන අවශ්‍ය දෙයක් තියෙනවා ලියා ගන්න පුළුවන්. Question number 21. You are requested to create 16 subnets with class C IP. Which subnet mask is suited to create the subnet? Class C IP එකක් ගමු. Class C IP එකක මේ වගේ octets 4. There are 4 octets. The first 3 octets for the network ID and the last octet is reserved for the host ID. The last octet contains 8 bits. Last octet contains 8 bits. We have to create 16 subnets. 16 subnets. 16 is equal to 2 to the power 4. So you have to allocate 4 bits for the subnet ID and another 4 bits for the host ID. If you consider the last octet, 4 bits reserved for the subnet ID. So the subnet mask will be 255, 255, 255, dot 240 subnet mask. Then question number 22 is for the question number 21. The answer is the first answer. Question number 22. Which of the following statements regarding the testing of a system are correct? So here it's a very important question. So if you go back to past papers, testing is very important because testing is asked in most of the questions. The testing phase in the system development life cycle, the testing phase, there are two testing strategies: black box testing. In black box testing, you consider the system and input the data and consider the output. Check whether the required or check whether the expected output is obtained by providing the input. Only the input output is tested for errors. If the expected output is not received, then you have to check the system. We never examine the codes. That's the black box testing. Then the white box testing, white box or the glass box testing. White box or the glass box testing, you have to examine each and every line of code. The code line should be translated and code line should be checked for errors. Then the next code line likewise. Each and every code line is tested for errors. If there's an error, there can be some logical errors, then you can correct them. For the white box testing or the glass box testing, there should be a person with very high level of knowledge about the coding. Then there are steps used in testing. You know, the unit testing, integration testing, system testing, user acceptance testing. What is meant by the unit testing? The software is made as the modules. Each and every module is tested for errors. This is done by the developer. It's called unit testing. Then each and every module should be integrated with another module. When integrating these modules, there can be some errors. So it should be tested for errors. It's called the integration testing. The system testing means the complete whole system. Once the whole system is obtained, the complete system is tested for errors. This can be done by the development team or sometimes by another quality assurance team or the specialized system team, testing team. User acceptance testing is the last one. We test the system for errors in front of the users. Then we can get the users' feedback and test the system, and if there's any changes, we can do them as necessary. All these things should be kept in mind when going through this question number 22. Which of the following statements regarding the testing of a system is correct? A. Black box testing involves detailed checking of each line of the code. Wrong. White box testing is testing in detail the lines of codes, not the black box testing. Statement B. Unit testing helps to uncover errors in the codes. Yes, you can identify errors using the unit testing. It's correct. C. System testing should not be performed prior to the unit testing. Yes, you have to perform the unit testing first, then the integration testing, then the system testing likewise. So C is correct. B and C only for the question number 22. 5. Answer 5. Which of the following indicates the functional requirements? Functional requirements. Functional requirements explains the function or a service of a system. A. The user should be allowed to update their contact addresses and phone numbers. It's a functional requirements, yes. is correct. Any user request must be responded within 2 milliseconds. No, it's a non-functional requirement. It's related to the performance. So the how long it takes to provide the output. C, the system must be easy to change. It's again maintainability. It's a non-functional requirement. A is correct. A only for the question number 23. The answer is the first one, A only. If you want to write down something, you can pause the video and write down. Question number 24. The following details are given out of a software project. We discussed the question number 23, we completed. Yes, the question number 24. The following details are given about the software project. A, requirements are fixed, not allowed to change throughout the complete project. So requirements are fixed, no changing in between the project. B, must deliver the complete software product at once. So you can't deliver the product part by part, it should be completely delivered. C, detailed descriptions and specifications must be prepared for each activity within the project. Yes. What is the most suitable software process model for this project? The waterfall model. For the question number 24, the waterfall model is the answer. For the waterfall model, the requirement gathering phase is at the beginning. So you have to clearly understand the requirements, and also the complete system is delivered at the end. No partial system parts are delivered. Question number 25. Which of the following statements on DFD is incorrect? Context diagram is a DFD with the highest level of abstraction. Yes, correct. Under the context diagrams, we model the system, the complete system, as a single unit. We provide the inputs and get the outputs. Inputs are sometimes provided by the external entities like this. Outputs are taken by the external entities in this manner. Then all data stores in a system must be represented in the context diagram. No, it's wrong. Data stores are not represented in context diagrams. Data flows are used to link the other components in DFD. Yes. Elementary processes are not decomposed further. Yes, when we are modeling the DFDs, level 1, level 2, elementary processes are not decomposed. External entities in DFDs act as a source or the recipient of data. Yes, external entities as a source or the recipient. Yes, the second answer is the answer for the 25. The second answer. So no data stores can be added to the context diagrams. It can be added only for level 1 and level 2 diagrams. What is the correct SQL statement to delete a database called ALDB? Drop database ALDB is the answer for the question number 26. So it's very easy. For deleting a database, you have to use the drop command. Delete command is for deleting the data within the table. Question number 26, the answer is 4. Question number 27. Which of the following statement about a relation in the second normal form are true? Normalization question එක. ඔන්න හොඳ question එකක්. Normalization මතක ඇති. Just consider about the 1NF all attributes should be atomic, no multi-valued attributes. 2NF should be in 1NF and 2NF relations are in 1NF, and all non-key attributes should fully depend on the primary key. 3NF, no any non-prime, no non-prime attribute, no non-key attribute transitively depend on the primary key. No non-key attribute transitively depends on the primary key. These are the main things you have to consider. For 3NF, it should be in 2NF, and no non-prime attribute transitively depends on the primary key. දැන් මේවා මතක ඇති කියලා හිතලා මම පොඩ්ඩක් මතක් කළේ. Which of the following statements about the relation in second normal form is true, are true? It can have a composite key. Yes, in 2NF relations, maybe there can be composite keys but no partial dependencies. All the non-key attributes should depend on the fully depend on the primary key in this manner. It should be a full dependency. If it's a full FD, it's 2NF. There can be composite keys. B, it should be in the first normal form as well. Yes, definitely. To become the 2NF, it should be in 1NF, and all the non-key attributes should depend on the primary key. Then C, all non-key attributes are fully functionally depend on the primary key. Yes, definitely. All the non-key attributes should fully depend on the primary key. So, for the question number 27, all ABC. Correct? 5. Yes. 27 is 5. 28. Which of the following statements regarding the logical database schema are true? Logical database schema contains the relational schema, primary keys and foreign key constraints are added. It's a blueprint for a database. Yes, A is correct. For question number 28, A is correct. It contains data and information. B, wrong. Logical database design does not contain data and information. C, it formulates all the constraints that are to be applied on the data. Yes, constraints are added. For the question number 28, answer 3. It's very easy. අවශ්‍ය දෙයක් තියෙනවා නම් ලියා ගන්න පුළුවන්. Question number 29. Consider the following SQL statement. Alter table subject, add primary key, subject ID. Alter table subject, add primary key, subject ID. So there's a table called subject, there's already a table called subject, there's no primary key mentioned, there's a field called subject ID, it is taken as the primary key. It is taken as the primary key. So then according to the question, which of the following is incorrect about the SQL statement? It adds the primary key constraints to the table name subject. Yes, the first one is correct. Primary key constraint is added. The second one, the table name subject should already exist. Yes, should be there. It's correct. Third one, the field subject ID should not be null. The field subject ID should not be null. Yes, if you make a field primary key, no null values are allowed. It's correct. The question number 4, the answer 4. A table name subject is created with a primary key named subject ID. Wrong. No table is created, it's already created. We are just mentioning or creating the primary key using an existing field. Question number 5, the answer number 5. The values of the field subject ID should not be repeated in subject table. Yes, no repeating values in the primary key. All the values should be unique. Answer 5 should be correct. It's the question number 29. Then we go to the question number 30. 30 has a small description, 30 and 31. You are supposed to draw the ER diagram. You are given the ER diagram, you have to select the correct ER diagram. It's a very important question. An author can write books. A book has a title and a code called ISBN, which is unique. A book can be written by either one or several authors. An author has a name and a unique ID. An author can have a type as either chief author or co-author for a particular book. Which of the following is the most suitable entity relationship representation for the above scenario? So, the book has a title, has an ISBN number. It's the primary key. Book is written by, writes by an author. Author is identified by the ID, the name, ID and the name. Author has two types of authors, chief author and the co-author. It's the type of the author. The type attribute is given here because for a particular book, there can be two authors. One author is co-author, the other one is the chief author. The same person may be another type in another book. So many-to-many relationship, a book can have many authors and an author can have many books. So the second answer for the question number 30, the second one is the answer. Then how many tables can be derived initially when mapping the entity relationships in the above scenario to a relational schema? මෙන්න මේ ER diagram එකෙන් අපි relational schema එකක් හදන්නේ කොහොමද කියලා අහනවා. Tables හදන්නේ කොහොමද කියලා අහනවා. There's a table called book which contains ISBN and the title. There's a table called author which contains the ID and the name. Since this is a many-to-many relationship, there should be a relation for this one. Say book author should contain the ISBN here, ID and the type. So ISBN here, this here. So 3 tables are created for 31, 3, 3. වීඩියෝ එක පෝස් කරගෙන ඔයගලන්ට ලියා ගන්න පුළුවන්. Right. I think questions 31ක් මේ වෙදි කළා. 31 questions already completed. So from 32, 33, 34 they are Python questions. දැන් අපි අද ගොඩක් දේවල් ඩිස්කස් කරපු හින්දා මම අද ක්ලාස් එක මෙතනින් නවත්තනවා. ඉතින් මේ ප්‍රශ්නෙටයි උත්තරේ විතරයි නෙමෙයි ඩිස්කස් කළේ. තියරි එකට අදාළ බෑග්ග්‍රවුන්ඩ් එක ගොඩක් මම එක්ස්ප්ලেইন කරගෙන ගියා, මතක් කරගෙන ගියා. අමතක වෙච්ච තියරි කොටස් ඔයගලන්ට අහුවේ මේව කරද්දි ඒව නැවත බලලා ගොඩ දාගන්න මතක් කරගන්න ඉස්සරහට මම පේපර්ස් ඔක්කොම කරගෙන යනවා පිළිවෙලට ඉංග්‍රීසි මීඩියම් හැමෝම අපිත් එක්ක එක්සෑම් එක දක්වා රැඳෙන්න මට පුළුවන් උපරිම වැඩ ටික මේ ඉතුරු කාලේ කරලා අවසන් කරනවා. හරි හැමෝටම තෙරුවන් සරණයි ආයුබෝවන්.